This is the real Tom Rose, and this is a really interesting problem. It looks like by convention, because usually x's and y's are your variables and k and m are constants. It looks like by convention they're giving you the variables and asking you to solve for the constants. But if you want, you don't have to think of it that way. You can think of it as they're telling you the constants and asking you to solve for the variables, which makes this a totally normal problem. So I'm going to just plug in these numbers for variables, x and y. So you'll get, say x is 3, so we'll get 3k plus 2m equals 7. And on the second equation, we'll get 2k plus 3m equals 5. So you can think of this as, hey, we have a system of equations with two variables, k and m, solve. I'm going to do this as a linear combination. There's no good way to do this. It's going to get ugly no matter what. You can already tell that by looking at the answer choices. It's going to be fractions, pretty much no matter what you do. If you have a calculator that does matrix math, this is a really good time to deploy that, so you don't have to think at all. If you don't know, if you haven't done that before, look up Gauss-Jordan elimination. If that's on your calculator, this will take 2 seconds with that. But I'm going to do this out longhand. Okay, so let's multiply by, what, 3/2? You'll see why I'm doing it this way in a moment, but I'm going to multiply everything by 3/2. 3/2 in the second equation. So what we're going to end up with is, I'm going to rewrite both equations so you can see them lined up, which will make it more clear why we're doing it this way. We end up with 3k plus 9/2 m equals 15/2. And the reason why we did it that way is so that we could line up these variables and subtract, and the k's would cancel out. So 3k minus 3k is 0. So you end up with 2 minus 9/2 m equals 7 minus 15/2. I'm going to multiply everything by 2. Let's do that in a different color. I'm going to multiply everything by 2 to make this easier to handle. So we're going to end up with 4 minus 9 m equals 14 minus 15. So you end up with negative 5 m equals negative 1, or m equals 1/5. Please let there be only one of those. Blast! So we know it's not this. Get rid of anything where m's not 1/5. So we gotta get rid of this one, we can get rid of that one, and we can get rid of this one. Unfortunately, we do have to plug in m equals 1/5 to determine whether k is 11/3 or 11/5. Aye. So let's plug in m equals 1/2, and we'll plug it into, or m equals 1/5. Let's plug it in here. And switch colors again. So we get 3k plus 2 times 1/5 equals 7. We'll solve this for k. So we get 3k plus 2/5 equals 7. 3k equals 7 minus 2/5. Multiply everything by 5, so we get 15k equals 35 minus 2. 15k equals 33. So k equals 33/15, which simplifies to what? Divide by 3, and we get k equals 11/5. So it's the first one. Whew. That was an annoying problem, huh, guys?